everyone, this is Praveena. I'm going to explain you an interesting topic that we come across in everyday life. We all use Google Maps to find routes to some places. Also, we use to find nearest restaurants or some places. In social medias like Facebook or Instagrams, we get friend suggestions, right? And many more such examples in real life. In all these scenarios, we come across some of the mathematical concepts that is involved in it. For example, for representation purpose, we use graphs, and for processing purposes, we use algorithms, and finally, we obtain the displayed results, right? Today we are going to discuss one such important algorithm that is used behind it, which is Floyd-Warshall algorithm. Let's get started. Floyd-Warshall algorithm. Before getting into it, let's look into some of the prerequisites that is needed. Graph. As you could see in this picture, this represents the graph where A, B, C, D are the nodes and we see the edges connecting these nodes. In a directed graph, the edges are given directions. In a weighted graph, the edges are given weights. So the graph that you could see here is a directed graph as well as a weighted graph. What is the shortest path? Shortest path is a path with minimum distance between two vertices. Some of the algorithms that is used for finding shortest paths. They are Dijkstra's algorithm, Bellman-Ford algorithm, Floyd-Warshall algorithm. Dijkstra's algorithm and Bellman-Ford algorithm are used to find distance between two vertices, say the first vertex, beginning vertex and the end vertex. So in this case, Dijkstra's algorithm is used when there is no negative edges. Bellman-Ford algorithm are used when there are negative edges but not negative cycles. Now Floyd-Warshall algorithm has a special property wherein it yields the shortest distance between every pair of vertices. Let's see what is Floyd-Warshall algorithm in detail. Floyd-Warshall algorithm is used to find APSP, all pair shortest path. This will hold for negative edges but not for negative cycles. Negative cycles means in a directed graph, the directed cycle that is present should not be of negative weight. If so, we will not be able to use Floyd-Warshall algorithm. And this Floyd-Warshall algorithm uses a dynamic programming approach where at each stages we need to make certain decisions. Those decisions is what we are going to use for the next stages. Before starting with the algorithm, we want to construct two matrices. One matrix represents the distance matrix, the other matrix represents the root matrix. Distance matrix represented by D is also the adjacency matrix. Let's see how do we construct it. We draw the matrix like I represents the rows and J represents the column. For the vertex I and vertex J, the distance Dij is given as the weight that is present in the graph. Okay, for that particular edge, whatever the weight that is present, it is given as Dij. If there is no edge between I and J vertices, we give them Dij to be infinity. If I is equal to j, that is the same vertices, we're going to find the distances. That means the distance will be 0. So the Dij's for I equal to j will be 0. Root matrix with rows entries as the column headings. Let's see in the detail what is the algorithm is. So the algorithm can be divided into two main stages. It has stage 0 and stage 1 to n, which is the general steps you need to follow. In stage 0, we construct the distance matrix D naught and the root matrix S naught. Just now we saw how to construct the distance matrix and this root matrix. Same way, we initialize for the given graph the distance matrix and the root matrix. Now we move on to the next stage, that is stage 1 to n, which is the general steps. We consider stage K, where in the kth stage we fix kth row and kth column entries. Now this becomes blocked elements or blocked cell. Starting from the first unblocked element until the last unblocked element, perform these two steps for every cell. For the unblocked elements, we are going to perform these. Well, let's see what are the two steps. If dk of I comma k plus dk of k comma j is less than dk minus 1 of I comma j, we replace dk of ij with dk of I comma k plus dk of k comma j. Else, we retain as it is. That is, we retain dk of I comma j with dk minus 1 of I comma j. If the change has occurred, that is, we have updated the distance in that particular stage, kth stage, what do we do to the same cell in the root matrix? If the changes occurred at stage k, the sk of I comma j will be equal to k, else it remains. After applying the algorithm, how do we interpret the results? The stopping condition could be dn and Sn has to be reached. That means you should have fixed all the rows and columns. Or if two consecutive D matrix and S matrices remains unchanged, that means there is no updation has taken place, then we stop. So that is also one of the stopping conditions. So there are two things that we need to look into. The DN matrix entries indicates the required solution, which is the shortest distance between every pair of vertices. SN matrix entries indicates the root of the shortest path, which is the shortest route between every pair of vertices. Now, DN gives the distance values and SN gives the root. So, we'll see how to interpret that roots as well. If the last matrix Sn of I comma j is equal to j, that means the root is just from I to j, is the what you have got the minimum distance. If not, else if you are having Sn of I comma j is equal to some other k, if it is not equal to j and it is equal to some other k, then our root will be from I, we move on to k, then we move on to j. So this k, there can be many number of k's that we need to keep into mind. Okay. Let's take a real life example and start. So the example I've considered is, find the shortest path between every 5 places. Kalasipalya and 4 different campuses of Christ in Bangalore using Floyd Warshall algorithm. So Kalasipalya, Central Campus, Bannerghatta Campus, Yeshwanthpur Campus and Kengeri Campus are the places that we are looking for the shortest paths. Have collected the data using Google Maps. So the data in the matrix represents the distance in terms of kilometers. So from place 1 to place 2, it is 5.2 kilometers. And from place 1 to place 3, it is 11 kilometers. Directed graph that I am representing here. And the matrix represents the adjacency matrix where the entries are all the distances in terms of kilometers. Along with this graph and the adjacency matrix, what do we do now? We construct the D0 and S0 matrix. So that is our stage 0. So now we start applying Floyd Warshall's algorithm. Stage 0. So the black color entries that you could see in this matrix represents the D0 value and the red entries will represent the S0 value. So for 5 vertices, we are having 5 cross 5 matrix. And the diagonal elements, for simplicity, I have crossed it out because we will not be updating. So this is the stage 0 and this is the matrix that we are obtained. Moving on to the next stage. So as I told in the beginning of the algorithm, at the stage, that is a general step, we fix kth row and kth column. So at stage 1, what do we fix? The first row and the first column. Yellow color cells meaning it is being blocked or it is fixed. So we are not going to touch it. So it is blocked. So the remaining cells are the unblocked cells that I mean. Now what I do? I start applying the 2 steps that I told in the beginning to every of the unblocked cells. The first step is to check the distance and the second step is to change in the root. It's very easy. So let's do it simultaneously. So I'm fixing the first unblocked cell by the green color mark. So that is been represented here. And then I take the first unblocked cell distance value, which is 7.3. Now it is very easy if you don't want to go with the formula that I've given in the algorithm. Another easy method is there. So now I'm taking a unblocked cell, right? So that unblocked cell see the blocked row value and the blocked column value. So add those two. Check whether this is less than the existing value. If it is less, update this. If it is not, don't update it. Okay. So here I have added 4.6 and 11. So I've got 15.6. So minimum among these two is what I will update. So which is 7.3. There is no changes that is happening. Now moving on to the root value. Now we saw D23 is equal to 7.3. There is no updation. And S23 remains same, which is equal to 3. Right? So this is what. Next. Similarly, in the next cell, when I add 4.6 plus 17, that is the row value 4.6 and the column value 17, I get how much? 21.6. Okay, since the change has occurred. Now let's see how to update the root value. So the root value here, by fixing the first row and first column, that is at the stage 1, you are able to see the updation. So just replace the stage value in that place. So the red color value which is over there is here 4 will be replaced by the stage value. What is the stage value here? It is 1. So the 4 is replaced by 1 and the 26, the value we have obtained, new value is 21.6 is replaced. So finally we see that root is changed. So the root is like 2 to 1, then 1 to 4. We calculated what are the changes and we have updated it. Moving on to the next unblocked cell, the distance value is 30 and the root value is 5. Now add 4.6 plus 21, which gives me 25.6. So I clearly see there is a change. So what I do, I update the distance value and the stage is 1. So I change that root value 5 by 1. That means via 1, I am reaching 5 from 2. Similarly, I will see the changes for every unblocked cells. So let's see. We have seen a change. That is 15 plus 5.2 is 20.2. So it was 22. So which is the value is less. So I will change. And similarly, I will change the root value as well. For the next as well, 15 plus 11 is 26. But the value it is having is 28. So I change it by 26. And similarly, the root value to be 1. Last unblocked cell. So now I stop stage 1 and I see what are the outcome. There are 4 cells that has undergone changes. Right? So this is what. Now whatever the matrix I've got in stage 1, I will be using in stage 2. So this is the updated values. Let me take you to the stage 2. Now in stage 2, what do? We fix the second row and second column. So we have fixed. Now after fixing, next step what should we do? We should see the unblocked cells. So starting from the first unblocked cell till the last unblocked cell, I should perform the operation that I told it before. So let's take the first one. Now the first unblocked cell, the value, original value is 11. 5.2 plus 7.3, that is its row value and its column value add. 5.2 plus 7.3. Clearly I could see it is a greater value than 11. So I don't change 11, I keep as it is. Since there is no changes occurred, the root value will remain same. Moving on to the next. Similarly, I will see if any updation is needed in every unblocked cells in stage 2. As you could see, there is no changes as happening. So if I take any value, say 35, its row value is 20.2, its column value is 25.6, which is a very huge value than 35. So I retain it. Similarly, every cells are retained its own value. There is no changes as occurred. So in stage 1 to stage 2, there is no difference. Let's move into stage 3. Stage 3, what do? We fix third row and third column. So I fixed third row and third column. Again, I see there is no changes. So which means this is my stopping conditions. But for clarification, I have done stage 4 and stage 5 also. Why should I do still stage 5? Because I have 5 vertices, I need to do n, that is 5 stages. In the 4th stage, I fix 4th row and 4th column. And I see, check for the unblocked cells, is there any updation is happening? There is no updations. So we move on to the next stage, that is stage 5. And again, I see there is no updations by fixing 5th row and 5th column. Yeah, we have completed all the stages that is required for Floyd Warshall algorithm. We have performed almost all. Now the last step is the interpretation. So I take one of the value that is changed and tell you the interpretation. So I will take the 21.6 and 1 which I changed in the first stage, the first one. The shortest distance between 2 and 4, the vertex 2 and vertex 4, which is 21.6 kilometer. And the value, that root value 1 indicates via 1 I have reached 4, right? Which means like S5, that is in that 5, between 2 and 4 the root value is 1, which is not equal to 4. That is S5 of 2 comma 4 is not equal to 4, but S5 of 2 comma 4 is equal to 1. So the shortest route between 2 and 4 is from 2 to 1, then to 4. Similarly for the next, 25.6 indicates the shortest distance between the vertex 2 and 5 and via 1. 20.2 and then 26. And the other cells as remains unchanged. So this is how. So I've considered the distance value in kilometers, assuming that there is no traffic and we are using our own transport facilities. This is the minimum kilometer that would be requiring to reach the different places from different other places. Thank you. Hope you enjoyed the video.